Welcome students to another information technology class. Today we will be focusing on problem solving, and this is in section 2 of the objectives in your CXC IT syllabus. Now we need to know what our objectives are for today. Now, our objective 1 is to outline the steps in problem solving. Definition of the problem, propose and evaluate solutions, determination of the most efficient solution, develop and represent algorithm, test and validate the solution. So those are our objectives for today. Now, a problem is a discrepancy between what is required and what exists, whereas a solution is a procedure consisting of a set of instructions that, if followed in order, achieve the required results. Now, you might be wondering, what is problem solving? Okay, no worries. Just take a minute to think of a problem that you might have. Is it to bake a cake? The problem could be to clean the house. The problem could be to be on time for your school session. Now, problem solving is the process by which a person finds the best solution to a situation that requires a solution. All right? So those problems that you thought about, yes, it requires a solution. All right, now we are going to be looking at the stages in problem solving. And one of the stages is to define the problem. And in defining the problem, you say what the problem being faced is. All right, as I said before, is it to bake a cake? That could be a problem. What is that problem? And that is defining the problem. The second step is to propose and evaluate solutions. That is, come up with a list of solutions or approaches that may solve the problem. Thirdly, determine the most efficient solution. That is, choose the best solution. 4. Represent the most efficient solution in the form of an algorithm. An algorithm is a step-by-step process in solving a problem. And finally, test the algorithm. Check if the problem is solved after solution was implemented. Okay, now we're moving on to the statement of the problem, right? Now, a statement of the problem, you might be wondering, what is it? Now, it is a clear definition of the problem that needs to be solved. The statement must be clear, concise, and unambiguous, meaning not too wordy. You know, some persons may be typing or maybe solving problems and they have a long, lengthy thing. So it must be unambiguous. So it must not be too long and drawn out. Okay? Straight to the point. The statement should not exceed 2 sentences at most. All right? And that's how short it should be. It should be brief. The program will accept values for 2 ages of students and calculate the average age. The average age is to be displayed. That could be a statement of the problem. The next statement of the problem is the program will accept 3 numbers and calculate their sum. Output of sum is to be provided. Now, are these whole numbers or are they percentage? You might ask. Let's move on. Now, if we should be given a problem to solve, say, for example, adding 2 numbers together to get a total. Let's look at what we will do. Now, this is called a defining diagram, otherwise called IPO chart. Now, the I means input, the P, processing, and the O, output. A table diagram with 3 columns that summarizes the inputs, processing, and outputs of the program or problem. That is what we call a defining diagram. Now look at this example. Write a program to read 2 numbers and print the total. Now our input would be to read the 2 numbers. So we are going to tell the computer now to read or accept or input the 2 numbers. And we will say read num1, and num1 is shortened for number. Num2. Alright, read num2. After which we'll have the processing, where we will actually be writing back what we input under the process. So we're telling the computer now to read num1 and read num2. After which we tell the computer to calculate the total, and then it will print the total, which is then our output. Now you might be wondering, what is input? Now, input is what data will be placed into the computer. And you use the keyword read. And it is used to record this. Now, another keyword for input is accept, enter, right? Input, you name it. Those are some keywords. Processing. What actions will be taken to derive the output? And in processing, there must be some form of action being done, like calculating, displaying, etc. Okay, as you can see in our example here. The output is the results that is to be achieved after you have input and something in, and it is processed, then you will get your output. Okay. Moving on. Now, okay, sorry about that. Now, say for example, we have a problem here, a problem statement. It says to read the price of an item and its type. A 5% discount is to be given on all books. If the item is a CD, then there will be a 10% discount and 2% on all other items. Calculate calculate and print both the discount as well as the discounted price. Now you might be wondering, how do we do that? It's too much information, man, but don't worry. We use the IPO chart, which is the first thing that we do when we are solving the problem. We break it down into significant parts so that it's easier. So the first thing we would do in terms of this question is to read the item name, tell the computer to read the item type and the item price. After which, then it will be processed, right? By reading the three items. The item name, type, price. Then the computer will calculate the discount, and then it will calculate the discounted price and print the discount and the discounted price. This will be your output, and the keywords for output is print, display, write, and the list goes on. Moving on. Another question could be, construct defining diagram for a program to print the larger of two numbers. Now we don't know what the larger of the two numbers are, so we are going to break it down. So our input would be read num1, num2. After which the computer will process the two numbers that are read and then determine the larger of the two numbers. Then it prints larger, which is our output. Okay. Moving on. The next example is write a defining diagram to read in two numbers, calculate and print their sum, difference, and product. Now the input would be to read the two numbers, right? After the computer read the two numbers, it will calculate the sum, calculate the difference, and calculate the product. After which it will print the product, the sum, and the difference, and that will be your result, which is your output. Number 4 example, construct IPO to read an employee's hourly rate and hours worked. Calculate and print total wages. Our input would be read hours, read rate. Our processing would be read hours and rate. And then we'll tell the computer to calculate the wage and print the wage, which would be our output. Okay, another example. Employees are paid 1.5 times hourly rate for each hour over 40 hours. Read the number of hours and the rate being paid. Print the total wages for the employee, including overtime. Now you might be wondering, what is this? How can this be done? Let's go. Read hours, so you tell the computer to read hours and read rate. And then you will ask the computer to set the rate at 1.5, okay, which is time and a half. After which the computer will process that, which is to read the hours and the rate, calculate the normal hours, which is hours minus 40, and calculate the normal pay, normal hours times rate. And then it will calculate the overtime pay, which is OT right here, overtime pay. And then it will output the total wages. Another example, and I'm giving you a lot of examples here. Write a program to enter the base and height of a triangle and print the area. Now you will tell the computer to read the height, read the base. and the list goes on.